Okay, the first part of this problem should be familiar for you now, but the second part can be a little bit, it's not straightforward. Okay, I don't want to use the word tricky because it's not tricky, but it's not straightforward. You need to do something, to do some conversion in order to answer the question. So here we are talking about number of pizzas consumed per month by university students, and we are given that this number is normally distributed, okay, which is something very valuable for us because then we can say a lot about the X bars. So it has a mean of 10 and standard deviation of 3, okay, and the question is what the proportion of students what proportion of students consume more than 12 pizzas per month. Okay, so what's our variable here? Our variable is X, which is the number of pizzas consumed by a student or university student per month. Okay, it's very important to always define your variables. So what do we know about that variable? We are given that it follows a normal distribution, and we're lucky enough that we have the parameters of this distribution, 10 and 3. And the question is, now we can convert it into probability statement. Remember that proportion is probability, right? So, excuse me. So this is probability that X is greater than 12. It's exactly the same thing that we were doing so far. We do the standardizing. And remember, this is the standard deviation. This is the mean. So it's 1 minus P of Z less than 0.67. We read it from the table. We get this. And this is the final answer. So that was, again, a repetition of the same procedure that you were doing before. So hopefully that you could have done it on your own. But read part B. What the probability that in a random sample of 25 students, more than 275 pizzas are consumed, right? So here we're talking about a total, and the author of the textbook is a really very nice person because he's giving you that hint. Okay, he's asking you what's the mean number of pizzas consumed by the sample of 25 students. Why he's giving you this hint? Because to answer this question, you cannot answer it using the probability of X. Neither you can answer it by using the probability of X bar, because this is the total consumption of 25 students, and this is not a variable that we know. We know the variable X, that's the number of pizzas consumed by a student, right? By one student, and we can define an X bar, which is the average of pizzas consumed by a certain number of students, but not their total. So what we have to do here is that we can come out with the mean, okay, of these 25 students from their total, right? Because we know the number of students, we know their total consumption to be 275, so we can get the mean, right? And why I want the mean? Because I need to use the X bar distribution to answer this question, right? About the total, which is the same. So I can tell that the 275 means that these 25 students have a mean X bar equal to 11 pizzas. So the probability that 25 students consumed more than 275 is equal to the probability that 25 students has a mean of X bar greater than 11. And that's it. And I'm now familiar with that. I know how to answer this question. P of X bar greater than 11, right? This is what we've been doing so far. Again, once you reach that point, you answer the question like any normal distribution question. Okay, so here we go. First of all, let's define it again. X bar has a mean of mu, which is the sample, which is the population mean, which is 10, which is given to us on the top. All right, here it's like this one, but the standard deviation is not 3 anymore, because this is the standard deviation of the population, but it's equal to 0.6, which is sigma X bar, sigma over square root of n, right? Which is this is coming from 3 divided by square root of 25, which is what which is 5, so it's 3 over 5, that's 0.6. And now I can write down my probability statement in an X bar terms, and everything is the same. You can notice here that I'm dividing by sigma X bar because this is my new variable here, X bar, and I get now this one. I read it from the table 0.9525, and I get the final answer of 0.0475. Okay, so I hope that that was clear. It's a very good application for the probability of an X bar. It's very important. Okay, now we move to an application for the probability distribution of sample proportion. Okay, so we are given that the probability of success on any trial of a binomial experiment is 25%. So what's that? It's an experiment, so we're talking about a full population, right? Because when we talk about probability, remember we learned that in earlier when we were introducing the topic of probability, that probability means long-term trials. So we have a large number of data. So this 25% is what? This is the population proportion, right? So we are given that the population proportion is 0.25, and the first question, find the probability that the proportion of successes in a sample of 500, right? So we did now 500 trials, and the question is we get less than 22%. So here we're talking about a sample, and it has a sample size of 500. And what do we know about the proportion coming out from that sample? Okay, it has a standard deviation, sigma p bar. We are given this equation. So I just plug here p, which I know is 0.25, and 1 minus p divided by n. And we get 0.194. So what can I tell about p bar? First, we need to find out whether it follows a normal distribution, right? So remember, we have a test for that. So let's test it. First, we find n times p, which is the sample size times the proportion of the population. 125 obviously greater than 5, and then n minus 1 minus p, we get also 375. So yes, we are confident it's normal distribution, so I can represent it like that. Okay, it has a mean equal to the population proportion, 0.25, and this is sigma p bar that we just calculated above. So now the question is, what the probability that this sample proportion is less than 0.22? I do the standardizing, and remember that the mean of that distribution is p itself. It has standard deviation sigma p hat, and we substitute the values here, and we get this one. We read it from the table, we get 0.06. Okay, so almost 6%. Part B and C is just a repetition of the first part, but here we're changing the sample size. So again, here I strongly advise you guys, because if you understood part A, you should be able to do it on your own. So I advise you, stop the video, try to answer the question first yourself, and then check your answers. So here, what are we doing? We're simply changing the sample size, which will only change our sigma p hat, and now it becomes 0.0153. I will go quickly here, guys, because it's exactly the same procedure, but I'm just underlining what's changing from previous part. And the probability is now here. Here we go again. I'm underlining what changes, which of course will change the value of z here. And we get 0.025 from the table. In part C, they are asking to check for a sample size of 1000. Again, here for that sample size, we get sigma p hat to be 0.0137, because this changed, nothing changed on the numerator, and which will change our value, of course. And the probability will be, first let me show you that. This will be now our new distribution. And I'm not testing for normality, because when you multiply 500 by n and 500 by 1 minus n, you get greater than 5. Certainly when you are multiplying by 1000 and 800, you will get greater. So I'm assuming that you'll do that on your own. And this is our probability statement, and we get a final answer 0.0143. Okay, so I hope that was clear enough. As I told you guys, once you reach a certain point, it's simply answering a question about a variable that follows a normal distribution. The last problem will be about the difference between two means. All right, so read this problem carefully. Here we are told that a factory worker productivity is normally distributed. This is again an excellent news for us. One worker produces on average 75 units per day with a standard deviation of 20, while the other worker produces an average of 65 per day with a standard deviation of 21. And the question is, what's the probability that during 1 week, and I'm going to come back to this point later, worker 1 will outproduce worker 2. Okay, so what do we have here? The daily productivity of each worker is a population by itself, right? Because you take every worker individually and you just record his productivity every day, and this record, you keep it, you accumulate the data, and this is a population of that variable. So we have, what do we know about worker 1? It has he has mu1, he has sigma 1, and we can say about x1, which is the productivity of worker 1, it's a variable that follows a normal distribution as given to us, and it has a specific mean of 75 and standard deviation of 20. We can see also another population, which is the productivity of worker 2, right? It has a mu2, it has sigma 2, and x2 has, it's another distribution, has a mean of 65, standard deviation of 21. And the productivity in 1 week, what's that? They are telling us that 1 week, assume that it's 5 working days. That means that we are selecting a sample, right? And this sample size this sample has a size equal to 5, right? Because out of all the productivities during all the days, we're selecting only 5 days, so it's a sample. Okay, so which means during these 5 days, worker 1 has a mean productivity, x1 bar, and worker 2 has a mean productivity, x2 bar. Okay, and the question is, what's the probability that x1 bar is greater than x2 bar? Since I know about a variable, which is the difference between two means, I will bring this guy to the left. Okay, and this will read, I'm sorry, now you cannot read it at all. Let me just erase that. Okay, so I brought it here to the left, which gets me here a difference between two means. Okay, and the question is, what's that? What's the probability that x1 bar minus x2 bar is greater than 0? What do we know about x1 bar minus x2 bar? We have learned about that this is a variable. It has a normal distribution with a mean equal to the difference between the population means, which I know, so that's equal to 10. And it has a standard deviation, a little bit more complex, the equation, sigma 1 square over n1 plus sigma 2 square over n2, and this gives me 12.97. Now I'm ready to write the probability statement, or to standardize it, right? Because I have already written it here. I just want to standardize by subtracting on each side of the inequality the mean and dividing by the standard deviation, which we just got at 12.97. So we'll do that. And here we go. I'm not writing this here because it's very large, so I'm just making it more concise, but I'm showing you here that I'm subtracting the mean, dividing by standard deviation, and when I did that here, it became z, and then it's like any other question about z. and we read this one from the table, and we get 0.7794. Okay, so I hope this set of problems was clear for you. I strongly advise you to do it on your own. And if you have any question, you know how to reach me. Thank you.